Have you ever looked at an image from the James Webb Space Telescope and felt a sense of profound vertigo? Not just because of the distance, but because of the sheer impossibility of what you're seeing. We gaze upon these infant galaxies, burning with a maturity that defies our cosmological timelines, and we are told they are ghosts from the dawn of our own time. But what if they are not ghosts? What if they are not from our time, or even our universe at all? Scientists are now grappling with a theory so reality-shattering it belongs in the realm of myth, yet the data insists we look. It suggests that some of these distant, puzzling galaxies might be leakage, echoes, or perhaps even doorways to a cosmos that exists alongside our own. As a cosmic engineer, when I hear the word doorway, my mind doesn't just stop at the discovery. It ignites with a singular, audacious question. Can we build a key? Better yet, can we engineer the entire frame? This is the ultimate engineering challenge. We are not talking about building taller skyscrapers or faster spacecraft. We are talking about the construction of the single greatest project ever conceived, engineering a bridge between universes, a multiverse gateway. This sounds like fiction, I know. It's a concept that feels fundamentally beyond our grasp, as if we are ants contemplating the construction of a transatlantic fiber optic cable. The laws of physics as we understand them seem to erect an impenetrable wall. General relativity, our masterful theory of the very large, describes spacetime as a fabric that can be bent and warped by mass and energy, but it offers no clear schematics for tearing it open and connecting it to another separate fabric. It's like having a perfect blueprint for a boat, but no understanding of how to make it leave the water and fly. On the other end of the spectrum, we have quantum mechanics, the strange and wondrous rulebook of the very small. It hints at the existence of other realities in the probabilistic haze of quantum foam, where universes might bubble up and pop out of existence in fractions of a second. It suggests that reality is far more fluid and interconnected than our senses tell us. But these hints are like whispers in a hurricane. How do you engineer with whispers? The energy requirements alone seem to present a vertical, insurmountable cliff face. To bend spacetime to our will, to stabilize a tear in reality long enough to be useful, theoretical calculations demand energies on the scale of entire stars, or perhaps even galaxies. We would need to harness the power of a supernova just to hold the door open for a fleeting moment. We lack the materials, the power sources, and most importantly, the fundamental understanding to even begin drawing a credible blueprint. This is the heart of the enigma. Why does this project seem so impossible? Because it requires us to be masters of two different physical languages, relativity and quantum mechanics, and to write a sentence that is grammatically correct in both. A sentence that the universe will understand and obey. We are trying to weld together the largest and smallest scales of reality. It's an engineering problem akin to building a bridge out of smoke and gravity, connecting a mountain peak to a dream. And yet, this is the philosophy of cosmic engineering. We don't see impossibilities. We see design challenges waiting for the right perspective. And this is where our investigation truly begins. What if the very things that make the project seem impossible are actually the clues to its solution? What if the key to building this bridge isn't to be found by generating unimaginable power here on Earth, but by looking out into the cosmos and finding the places where the universe has already done the hard work for us? This is the tantalizing promise offered by those strange JWST galaxies. What if they are not just distant objects, but engineering signposts? Points in our own cosmos where the veil between realities is naturally thin. Imagine the fabric of spacetime, not as a uniform, infinitely strong sheet, but as a vast, ancient tapestry, worn thin in places, stretched and stressed by the cataclysmic events of billions of years. A supermassive black hole's gravity, well, the collision of neutron stars that sends ripples through reality, or the exotic conditions of the very early universe. Perhaps these events create temporary or even permanent weaknesses, stress fractures. For an engineer, a fracture isn't a flaw. It's a starting point. It's the place you insert the wedge, It's the foothold that allows you to begin the climb. Our investigation pivots from a problem of brute force to one of cosmic acupuncture. The challenge is no longer about how to blast a hole in reality, but about how to find the precise pressure point and apply the exact right amount of energy and exotic matter to gently open a stable, traversable passage. This transforms the entire engineering paradigm. We are no longer cosmic conquerors, trying to bend the universe to our will. We become cosmic surgeons, identifying a natural anomaly and performing a delicate operation on the fabric of spacetime itself. The concept we will explore is that of a traversable wormhole, an Einstein-Rosen bridge, but one that doesn't just connect 2 points in our own universe, but 2 points in entirely different spacetimes, different universes in the grander multiverse. The Multiverse Gateway. To do this, we must delve into the bleeding edge of theoretical physics, into the realms of string theory, N theory, and quantum loop gravity. These are the theoretical frameworks that attempt to unify gravity with quantum mechanics, to find that universal language we so desperately need. They predict extra dimensions of space, curled up and hidden from our senses. They speak of brains, vast membranes of reality floating in a higher dimensional space. What if 2 of these brains, 2 separate universes, could be brought close enough to touch? What would be the engineering required to facilitate that contact and, more importantly, to stabilize it? This is what we will investigate. We will explore the theoretical need for something called exotic matter, a substance with negative mass or negative pressure, something that would act as an anti-gravitational scaffold to hold our gateway open against the immense forces trying to crush it shut. We'll ask, where could we find such a material, or how could we engineer it? We will examine the navigational challenges. How do you chart a course to a different universe with potentially different physical laws? How do you build a probe or a ship that can survive the journey through the throat of the gateway and function in a new reality? This journey is about more than just physics and material science. It is the ultimate expression of the human drive to explore, to push beyond every known frontier. For millennia, we looked at the oceans and saw a barrier. Then we built ships. We looked at the sky and saw a limit. Then we built wings and rockets. Now, we look at the very fabric of our reality, and we dare to ask, what lies beyond? Building a bridge to another universe would be the definitive act of our species, the moment we graduate from a planetary civilization to something far grander. It would be our legacy, a testament to the idea that no barrier is permanent, and no mystery is unsolvable when faced with the relentless ingenuity of the engineering mind. So, join me. Let us be the architects of the impossible. Let's pick up the tools of theoretical physics and the blueprints of our own ambition, and begin the serious work of engineering a bridge between worlds. Our investigation into the Multiverse Gateway starts now. Before any great structure is built, the engineer must first understand the ground upon which it will stand. They must know its weaknesses, its stresses, its fundamental limits. In our case, the ground is reality itself. And as we begin to survey the site for our Multiverse Gateway, we find it is not merely difficult terrain. It is a landscape actively hostile to our intentions, governed by laws that seem purpose-built to forbid this exact project. This is Phase 1, a sobering, unflinching look at the mountain of impossibility that stands before us. We must dissect it, measure it, and respect it, for only then can we hope to find a way to conquer it. Our first and most formidable obstacle is the very nature of spacetime. This is not the passive, empty void of classical imagination. Albert Einstein's theory of general relativity revealed it to be a dynamic, four-dimensional entity, a fabric. But this analogy, while useful, is too gentle. A fabric can be cut and sewn. Spacetime is more like a vast, infinitely dense ocean of self-healing energy. When we speak of creating a gateway, we are talking about punching a hole through this ocean. The problem is, the ocean doesn't want the hole to be there. The moment you create such a tier, the surrounding pressure of the entire universe would conspire to snap it shut with a violence that is almost instantaneous. We are talking about an instability on the order of the Planck time, the smallest possible unit of time. Imagine trying to build a bridge across a chasm that closes and reopens trillions upon trillions of times per second. That is the fundamental instability we face. And why is it so unstable? Because of gravity. In our universe, gravity, as far as we can measure it, is always attractive. It pulls things together. A wormhole, by its very definition, is an object of extreme gravitational curvature. The immense gravity required to connect two distant points in spacetime would, under all normal conditions, immediately collapse into a black hole singularity, creating not a tunnel, but an inescapable prison. So, our first engineering challenge is this. We must fight the most fundamental tendency of the universe. It's like trying to build a structure underwater that actively repels water, using only materials that are themselves made of water. The universe screams no at the very concept. Let's say for a moment that we could somehow solve the stability problem. We now face our second barrier, the energy catastrophe. The scale of energy required to perform such a feat is difficult for the human mind to truly internalize. E=mc is the most famous equation in history, and it is the brutal gatekeeper of this project. It tells us that mass and energy are two sides of the same coin, and to manipulate the space-time fabric, you need a quantity of mass energy that beggars belief. Forget nuclear power plants, or even the total energy output of our entire civilization. Those are firecrackers next to a supernova. Calculations suggest that to open a human-scale wormhole, just a few meters across, and keep it open for a meaningful amount of time, you would need a concentration of energy equivalent to that of an entire star. Think about that. Not the energy the star produces over a day or a year. The energy equivalent of its entire mass, converted to pure energy in a single moment. And this is just for a small gateway. A stable bridge, a true gateway, might require the energy output of hundreds of stars, or perhaps even a small galaxy. What does this mean in practical engineering terms? It means our power source cannot be something we build. It must be something we harvest. We would have to become a Type 2 civilization on the Gatewaygege scale, capable of harnessing the entire energy output of our parent star just to power the on switch. We'd need to build a Dyson sphere or some similar megastructure, not as a project in itself, but as a mere power supply for our primary construction. The sheer logistics of gathering, storing, and focusing this much energy into a single point without accidentally vaporizing our own solar system is an engineering problem orders of magnitude greater than anything we have ever contemplated. It's like a Roman engineer being asked to build the Colosseum, but being told his only power source is a controlled hurricane he must first create and contain. The power source itself is a more difficult project than the one it's meant to enable. Now we arrive at the third, and perhaps most esoteric barrier, the exotic matter paradox. This is where the problem shifts from merely impossible scales of energy to a challenge involving the very substance of reality. As we established, normal matter and energy create attractive gravity, which would crush our gateway. The mathematics of wormholes, first seriously explored by physicists like Kip Thorne, came to a startling conclusion. To counteract this collapse, to prop the tunnel open and create a stable bridge, you need something with anti-gravitational properties. You need a substance that has negative energy density or negative pressure. This has been given the name exotic matter. And here is the colossal problem. As far as we know, it doesn't exist. Every particle, every field, every form of energy we have ever observed or created, from rocks to stars to dark matter, all exert positive, attractive gravity. Asking an engineer to build with exotic matter is like asking a naval architect to build a battleship out of a substance defined as anti-buoyancy. It is a request for a material whose defining property is the opposite of what all known materials possess. It's a showstopper. We cannot mine it, we cannot synthesize it, because we have no working model for what it even is. There are some theoretical hints, tiny whispers from the quantum world. The Casimir effect, for instance, demonstrates that a vacuum is not empty, and it's possible to create regions between two plates that have a slightly negative energy density compared to the vacuum outside. But the amount is infinitesimal. Relying on the Casimir effect to hold open a wormhole would be like trying to stop a charging bull with a single spider's thread. It is a phenomenon, not a building material. So our project requires a substance that may be mathematically possible, but physically non-existent. We are being asked to build the keystone of our cosmic arch out of a ghost. Finally, even if we could overcome the barriers of stability, energy, and exotic matter, we face a fourth, deeply unsettling challenge: the information and predictability problem. Where and what are we connecting to? Building a bridge to another continent on Earth is simple, because you know the rules of geology and physics are the same on the other side. A multiverse gateway has no such guarantee. The other universe may have different fundamental constants. Gravity might be stronger or weaker. The speed of light could be different. The very nature of matter could be alien. Sending a probe through would be the ultimate gamble. It would be like testing a new submarine by sending it into an ocean we suspect might be made of acid. Furthermore, there's the black hole information paradox, which asks what happens to the information of things that fall into a singularity. A similar question applies here. Would a traveler retain their physical structure and information upon traversing the gateway? Or would they be disassembled into raw data and reassembled, perhaps incorrectly, on the other side? The engineering challenge, therefore, extends beyond construction. It's a problem of metrology and survival. How do you design sensors that can measure the physical laws of another reality from a distance? How do you shield a ship or a traveler from conditions you cannot possibly predict? It is the ultimate unknown unknown. The bridge could lead to paradise, or it could lead to an instantaneous physics-driven oblivion. Designing for one outcome is as baseless as designing for the other. This isn't a risk assessment. It's a blind leap into a new book of creation, and we have no idea if our language will even be legible there. These four pillars, the instability of space-time, the catastrophic energy cost, the paradox of exotic matter, and the uncertainty of the destination form the foundation of our impossible challenge. Each one, on its own, is a project for a god. Together, they represent a solid wall of physical law, seemingly declaring that our universe is a closed system. The sign on the door says, "No exit." Our task, as engineers of the cosmos, is to scrutinize the fine print. In the face of the impossible, the engineer does not despair. They begin the investigation. We have laid out the evidence against our project: the active hostility of spacetime, the galactic-scale energy costs, the non-existence of required materials, and the terrifying uncertainty of the destination. A prosecutor would declare the case closed, but we are not prosecutors. We are detectives, and we know that the universe, for all its apparent rigidity, is filled with loopholes, paradoxes, and secrets. It is time to look for the clues the cosmos has left behind for us, the natural phenomena that hint at a different set of rules. This is Phase 2. We follow the breadcrumbs of theoretical physics and observational astronomy to see if they lead us out of the labyrinth of impossibility. Our first clue addresses the foundational problem of space-time instability. We established that any tear in reality would snap shut instantly. We need an anchor, a scaffold to hold it open. The clue? Something called a cosmic string. To understand this, we must go back to the very first moments after the Big Bang. The universe was a crucible of unimaginable energy, and as it cooled, it went through phase transitions, much like water freezing into ice. Theoretical physics predicts that, just as cracks can form in ice, linear, one-dimensional defects could have formed in the fabric of space-time itself. These are cosmic strings. They are not made of matter in any conventional sense. They are lines of pure, primordial energy, thinner than a proton, but with an astronomical mass. A single meter of cosmic string could weigh as much as the Earth. They would stretch across billions of light years, remaining under colossal tension. Think of them as the universe's own internal reinforcement bars, sutures left over from its violent birth. And why is this a critical clue for our engineering project? Because a cosmic string represents a pre-existing, stable, linear region of extreme spacetime curvature. It is, in effect, a natural anchor. Instead of trying to create stability from nothing, we could build our gateway along one of these strings. The immense tension of the string could act as the stabilizing force, the backbone for our entire structure. It's the difference between trying to build a suspension ridge in mid-air versus finding two pre-existing, indestructible mountain peaks to anchor your cables to. The universe may have already provided the primary structural components. Our mission, then, transforms from one of pure creation to one of cosmic surveying, finding one of these elusive strings and engineering a way to harness its phenomenal properties. It doesn't solve the whole problem, but it gives our impossible structure its first potential foothold in reality. Next, we confront the energy catastrophe. How do we power a machine that requires the energy of a star? The clue lies in the most extreme objects we know of, black holes. For a long time, we saw them as simple cosmic drains, points of no return. But our understanding has become far more nuanced. A spinning black hole, known as a Kerr black hole, is not just a gravitational sink. It is the most efficient and powerful energy storage device in the known universe. Around a Kerr black hole is a region called the ergosphere. Within this region, space-time itself is dragged around by the black hole's rotation at incredible speeds. The physicist Roger Penrose discovered a theoretical mechanism, now called the Penrose process, for extracting energy from this region. It's a masterful piece of celestial mechanics. In essence, you can throw an object into the ergosphere and have it split in two. One piece falls into the black hole, while the other is ejected with more energy than the original object had. That extra energy is stolen directly from the black hole's rotational energy. What does this mean for our project? It means we don't need to build a power plant. The universe is littered with them. A supermassive black hole at the center of a galaxy is a power source of literally astronomical proportions. Its rotational energy can exceed the total energy output of its host galaxy over millions of years. This is our clue. The engineering challenge shifts from the impossible task of generating star levels of energy to the merely monumental task of building a station within the ergosphere of a spinning black hole to harness it. It's like ancient humans discovering fire. They didn't have to create energy itself. They just had to learn how to tame a naturally occurring source. But the clue of the black hole goes even deeper. What if it's not just the power source, but also a part of the gateway mechanism? The singularity inside a non-rotating black hole is a point. But according to the mathematics of a Kerr black hole, the singularity is not a point, but a ring. In theory, it might be possible to travel through this ring singularity without being crushed. And where would you end up? The equations suggest an exit into a different part of our universe, or perhaps, just perhaps, into a different universe entirely. The black hole becomes both our engine and our chassis, a power plant and the portal. Now for the ghost in the machine, the paradox of exotic matter. We need a substance with anti-gravitational properties to prop our gateway open, but none exists. Or does it? Our clues here come from the deepest and strangest realm of physics, the quantum world. At the smallest of scales, the Planck scale, space-time is not smooth. It's a roiling, chaotic soup of virtual particles popping in and out of existence, a concept known as quantum foam. In this foam, the law of conservation of energy can be briefly violated, leading to fluctuations of both positive and negative energy. The Casimir effect is a measurable manifestation of this, a tiny hint that negative energy states are physically real, not just mathematical artifacts. But this is still just a hint, not a solution. The real clue may lie in a grander theory, like M-theory, one of the leading candidates for a theory of everything. M-theory posits that our four-dimensional universe is just one brane, from membrane, floating in a higher dimensional space called the bulk. It also suggests that there are countless other brains, other universes, floating parallel to our own, perhaps only a microscopic distance away in a higher dimension we cannot perceive. Here is the engineering clue. Gravity, according to this theory, might be unique. It might be able to leak between these brains. What we feel as gravity in our universe could be just a fraction of its true strength, with the rest acting on these other brains. So, how does this help us find exotic matter? It offers a revolutionary alternative. Perhaps we don't need to create a substance with negative mass. Perhaps we can engineer a way to use the gravity from another brain to stabilize our gateway. Imagine two parallel sheets of paper. If you could create a strong gravitational pull on one sheet, it would cause a corresponding dimple in the other. If we can manipulate higher dimensions, we might be able to use the gravity of a nearby parallel universe to create a region of negative pressure in our own, effectively propping our gateway open with the mass of another reality. This is the ultimate engineering hack. We use the destination to stabilize the journey. We build the bridge by borrowing the foundation from the other side. Finally, we must address the unnerving problem of the destination. How do we build for an unknown reality? Our final clue brings us back to where we started. Those enigmatic images from the James Webb Space Telescope. Those galaxies that appear too bright, too mature, too impossible for their age in our universe's timeline. We initially framed them as a mystery. Now, let's reframe them as data points. What if these galaxies are evidence of a past, natural, inter-universal interaction? What if, billions of years ago, our brain brushed against another, older brain? Such a collision would have seeded a region of our infant universe with matter and stars from a more mature cosmos, creating exactly the kind of anomalies JWST is observing. This isn't just a fascinating theory. For an engineer, it's a gold mine of reconnaissance data. These galaxies are our probes. By studying their light, their chemical compositions, their stellar populations, and the very laws of physics that appear to govern them, we can learn about the universe they came from. We can search for subtle differences in atomic spectra that might hint at different fundamental constants. We can model their evolution to infer the gravitational environment of their home reality. This clue transforms the problem from a blind leap to a data-driven mission. We have a target location. We have a potential source of information about the conditions on the other side. Those distant galaxies are not just destinations. They are lighthouses signaling across the cosmic ocean, giving us the bearings we need to start drawing our charts. The case against our project, once seemingly airtight, is now riddled with doubt. The universe itself, in its most extreme and theoretical corners, offers us a cosmic string for a scaffold, a spinning black hole for an engine, the physics of higher dimensions for our impossible material, and ancient galaxies as our reconnaissance reports. The clues are here. The path is not clear, but for the first time, it is visible. An investigation reaches a critical point when the scattered clues on the evidence board suddenly click into place. A string of yarn connects a photograph here to a map there, revealing a pattern where before there was only chaos. This is that moment for us. We have faced the four great impossibilities: the violent instability of spacetime, the demand for stellar-scale energy, the paradox of non-existent exotic matter, and the blind terror of an unknown destination. And for each, we have found a corresponding clue, a whisper of possibility from the cosmos. Now, we weave them together. This is Phase 3, the ingenious connection and the technical thesis. This is where we stop asking, what if, and start defining how. Our thesis is revolutionary, not because it relies on brute force, but because it is a proposal for the most sublime act of cosmic judo ever conceived. We will not fight the universe. We will guide it, using its own immense power and most esoteric secrets to achieve our goal. Our technical thesis begins not with construction, but with cartography. This is our answer to the fourth problem, the uncertainty of the destination. We don't throw a dart at a map of the cosmos. We find the specific point where the barrier between worlds is already thin, already compromised. Our first step is the most ambitious astronomical survey in history. Using a new generation of deep space observatories, we will hunt for those JWST anomalies, those impossible galaxies. But we will look closer, analyzing them with a forensic eye. We are searching for a very specific set of signatures. Firstly, we analyze their light spectra for subtle deviations from our own universe's physical constants. This is our first glimpse into the laws of the target reality. Secondly, we look for unique gravitational lensing patterns around them, searching for evidence of massive linear structures, the telltale sign of a cosmic string. Thirdly, we look for gravitational wave echoes, the faint remnants of ancient cataclysms that might signal a past brain collision. This is our ingenious connection. We use the JWST anomalies as our survey markers. They solve the where and the what in a single stroke. This isn't just about finding a destination. It's about identifying a structurally sound and partially understood location for our bridge's far side abutment. We are choosing our construction site based on a cosmic geological survey, ensuring the ground on the other side is solid before we even break ground on our side. Once our target region is identified, a place where the veil between worlds is thin and we have a cosmic string to work with, we proceed to step 2, establishing our construction yard. This step tackles both the energy catastrophe and the spacetime instability problem head-on. Within our target region, we locate the perfect natural engine, a supermassive, rapidly spinning Kerr black hole. This is not just a convenient power source. It is the heart of our entire mechanism. We will construct a vast industrial and scientific complex in a stable orbit within its ergosphere. This megastructure is where we will harness the Penrose process, leading rotational energy from the black hole itself. This provides a virtually limitless supply of power, solving the energy problem not by building a star, but by tapping one that has already collapsed into the most efficient motor in the universe. But the black hole is more than a power socket. Its immense, stable gravity well, when combined with the tension of the nearby cosmic string we identified in our survey, creates a uniquely placid and predictable region of spacetime. It's like finding a calm, deep-water harbor in the middle of a raging cosmic ocean. The cosmic string acts as a guide wire, a linear anchor that dampens instabilities, while the black hole provides the raw gravitational footing. This is our second ingenious connection. We co-locate our power plant and our structural anchor. We don't have to transmit unimaginable power across light years. We build our engineering workshop right inside the engine room of the cosmos. Now for the technical heart of the thesis, the mechanism that addresses the great paradox of exotic matter. How do we open the door without the impossible anti-gravitational crowbar? The answer is elegance itself. We don't force the door. We persuade it to become permeable. This is where M-theory and the concept of vibrating brains come into play. Using the colossal energy siphoned from the Kerr black hole, we will construct an array of what can only be described as gravitational wave tuning forks. These emitters will not be designed to blast a hole in reality. They will be designed for precision. Their purpose is to emit gravitational waves of an incredibly specific frequency and phase, aimed directly along the cosmic string toward the thinnest point in spacetime. Think of reality as a grand musical instrument with many strings, each representing a universe. Our deep space survey of the target galaxy has allowed us to determine the approximate note of the other universe's brain. Our gravitational tuning forks then begin to play that exact note into our own brain. This is our third and most profound ingenious connection. We induce a state of macroscopic resonant coupling. Just as a singer can shatter a glass by matching its resonant frequency, we will cause our local patch of spacetime to vibrate in sympathy with the target brain. When the two realities are vibrating in perfect phase, the energy required to cross the dimensional barrier between them drops to a manageable level. A quantum tunneling effect normally confined to the subatomic world, is coaxed into existence on a human scale. This bypasses the need for exotic matter entirely. The stability of the gateway is not maintained by a physical substance propping it open, but by a dynamic standing wave of resonant energy. The negative pressure is an emergent property of two universes humming in harmony. We are not building a bridge of steel. We are building it out of music. This leads us to the final form of our gateway. It would not be a static, physical hole in space. It would be a shimmering, stable vortex, a persistent eddy in the river of reality. Its structure and stability are a direct consequence of our synthesized solution. The immense gravitational pull of the black hole provides the primary anchor. The cosmic string acts as a focusing conduit, a waveguide preventing our resonance energy from dissipating uselessly into the cosmos. The continuous stream of energy from the black hole's ergosphere powers the gravitational emitters, maintaining the standing wave that keeps the gateway open. The gateway itself is an emergent phenomenon, a triumph of alignment over force. It is a stable, traversable aperture created by the precise intersection of a Kerr black hole's power, a cosmic string's tension, and the resonant frequency of two parallel universes. Our final technical thesis is therefore complete. It is a multi-stage process of cosmic engineering based on finesse, not force. We propose that a multiverse gateway can be engineered by identifying a target region of spacetime where inter-universal proximity is indicated by cosmological anomalies, harnessing the rotational energy of a co-located Kerr black hole as a power source, utilizing a cosmic string as a stabilizing anchor and energy waveguide, inducing a macroscopic resonant coupling between the two universal brains via precisely tuned gravitational waves, thereby creating a stable, traversable gateway without the need for physical exotic matter. We have taken the impossible and rendered it into a sequence of engineering challenges. We have transformed a monster into a machine. The dream now has a blueprint. A blueprint is a promise. It is a declaration, in the language of mathematics and physics, that a dream can be made real. But the journey from paper to reality is the greatest gulf an engineer must cross. It is a journey measured not in equations, but in decades of toil, in mountains of material, and in the unwavering resolve of a civilization. This is Phase 4, the construction plan and the legacy. We will now detail the practical, multi-generational endeavor of raising this cosmic cathedral from the void, and then we will dare to look through its completed archway and glimpse the transformed future of humanity that awaits on the other side. This is the climax of our engineering investigation, where theory is finally forged into destiny. The construction of the Multiverse Gateway cannot be a project undertaken from Earth. The distances are too vast, the timescales too long. The very first step in our plan is therefore one of delegation, of seeding the cosmos with intelligence. We would begin by launching a fleet of von Neumann probes. These are not simple robotic explorers. They are self-replicating robotic systems, carrying the sum total of our engineering knowledge and the master blueprint for the gateway. Their mission, a centuries-long journey to the target system we so carefully selected. Upon arrival, their prime directive is not to build the gateway, but to build the factory that will build the gateway. Think of them as our robotic colonists, the vanguard of our ambition. They will harvest raw materials from the system's asteroid belts, moons, and barren planets, using this feedstock to create copies of themselves, expanding their numbers exponentially. This swarm, growing from a handful of probes into a robotic civilization of millions, will establish the entire industrial base we need. They will build the foundries, the refineries, the assembly lines, and the power systems. This is the only way to overcome the tyranny of distance. We do not ship a bridge across the ocean. We send the architects and a single box of tools, and they build a new industrial heartland on the far shore. This initial phase might take 1,000 years, a silent, automated ballet of creation unfolding in a distant star system, a testament to our foresight being laid down long before the main event. With the industrial infrastructure in place, Phase B of construction begins, the taming of the beast. The robotic swarm will commence the assembly of the primary engineering complex, the colossal station in orbit within the ergosphere of the supermassive Kerr black hole. This is perhaps the single most challenging piece of structural engineering ever conceived. The materials used would have to be beyond anything we currently possess, likely synthesized in the robotic foundries from neutron-degenerate matter or exotic metallic hydrogen alloys, designed to withstand the insane tidal forces and radiation environment. The station would be a ring-like structure, miles in diameter, composed of habitation modules for future human crews, scientific laboratories, and most importantly, the colossal energy extraction arrays. Imagine vast, city-sized electromagnetic sails, or scoops, dipping into the swirling vortex of spacetime in the ergosphere. They are designed to interact with the frame-dragging effect, slowing down virtual particles and converting that momentum into usable power via the Penrose process. This is the Hoover Dam of the cosmos, a megastructure designed to tap a force of nature so powerful it bends the fabric of reality. Its construction would be a slow, painstaking process, with each component ferried into place and assembled by legions of specialized robots, all under the guidance of the central AI consciousness that grew from the initial probes. The completion of this ergosphere complex marks the moment we turn the key on our galactic power plant. Phase C is the final, delicate, and awe-inspiring act of creation, the deployment and alignment of the gravitational resonance emitters. With the power of a black hole at our command, the robotic swarms will construct the tuning forks of our cosmic instrument. These are immense, crystalline structures, kilometers in length, designed to convert raw energy into gravitational waves with unparalleled precision. They are then transported and positioned with microscopic accuracy along the length of the cosmic string we identified, which now serves as a natural optical bench, a perfectly straight line drawn across spacetime. This alignment is the most critical part of the entire process. Using the string as a guide, the emitters are phased together, their gravitational wave outputs synchronized by a quantum computing network to create a single, coherent, perfectly tuned beam of resonant energy. Then, the activation sequence begins. Slowly, carefully, power is fed to the emitters. The song begins, a hum of gravitational energy that vibrates through the very essence of our universe. We would detect nothing at first. Then, our most sensitive instruments would register a strange resonance. And then, at the focal point, space itself would begin to shimmer. The light from distant stars would warp and twist as if seen through heated air. A small, stable, shimmering vortex would appear a tear in reality, held open not by force, but by a perfect, sustained note in the music of the multiverse. The Gateway would be born. And what then? What is the legacy of a project that took millennia to complete? The moment the Gateway is declared stable and open, human civilization is irrevocably and profoundly transformed forever. The first and most immediate impact would be the end of scarcity. Even if we only ever explore the other side with robotic probes, access to an entirely new universe means access to unimaginable resources. Planets, stars, nebulae filled with elements rare in our own cosmos. New sources of energy, but more profoundly, access to new knowledge. The data streaming back through the Gateway would catalyze a scientific renaissance that would dwarf all previous ones combined. We could study a universe with different physical laws, allowing us to finally unify our own theories and understand the true nature of reality. This newfound understanding would lead to technologies we can currently only dream of: gravity manipulation, zero-point energy extraction, perhaps even conscious control over matter. It would be an intellectual and technological Cambrian explosion. But the true legacy extends beyond resources in science. It touches the very definition of what it means to be human. What will we find on the other side? An empty universe, ripe for exploration and settlement? Or a cosmos teeming with life, Perhaps life so alien it challenges our fundamental understanding of biology. Or could we find other intelligence, other civilizations? The confirmation that we are not alone, not just in our galaxy, but in the grander multiverse, would be the single most transformative moment in the history of consciousness. Our philosophies, our religions, our art, our tribal squabbles all would be recontextualized into insignificance against the staggering backdrop of a living, breathing multiverse. We would finally understand that humanity is not the sole protagonist of the story, but merely one voice in a cosmic choir of infinite size. This knowledge would force a new level of maturity upon our species, a new perspective that could finally unify us. And finally, the ultimate legacy of the Gateway is that it is not an endpoint, but a beginning. It is proof of concept. The first one is the hardest. Once we have engineered one, we will know how to engineer others. Humanity's role would shift from a species clinging to a single planet to the explorers and pioneers of the multiverse. Our destiny would no longer be tied to the finite lifespan of our sun, our galaxy, or even our own universe. We would become a truly immortal species, capable of seeding life and consciousness across realities, stepping into a role as guardians or gardeners of the cosmos. The Multiverse Gateway is more than a structure. It is an act of transcendence. It is the moment our species takes its future into its own hands, turning the final page of our cosmic childhood and stepping into an adulthood of infinite possibility. It is the ultimate expression of our eternal, unquenchable desire to see what lies beyond the next hill. Even if that hill is an entirely different creation, our investigation is complete. We began with a flicker of anomalous light from the dawn of time, a puzzle presented to us by the James Webb Space Telescope. We asked a simple yet audacious question. What if that light is not a ghost from our own past, but a lighthouse from another shore entirely? This question led us down a path that seemed, at every turn, to be blocked by the very laws of physics. We stood before the four great walls of impossibility, a space-time fabric that violently resists being torn, an energy requirement that dwarfs the output of stars, a need for a building material that is nothing more than a mathematical ghost, and the profound uncertainty of what lay on the other side. The project of a multiverse gateway seemed destined to remain in the realm of fiction, a beautiful but fundamentally unattainable dream. But the core tenet of the cosmic engineer, of the human spirit itself, is to see a wall not as an endpoint, but as a challenge to be understood. And so, we began our detective work. We sifted through the most advanced and esoteric theories of modern physics, and we found clues. We found the possibility of cosmic strings, primordial sutures in reality, that could serve as our structural anchors. We found the spinning hearts of galaxies, Kerr black holes, and realized they were not just sinks of oblivion, but potential engines of creation waiting to be harnessed. We peered into the quantum foam and the higher dimensions of N-theory and saw not a need for an impossible substance, but a path toward a solution of elegant resonance, of coaxing two universes to hum in harmony. And we looked back at those strange galaxies and saw them not as a mystery, but as our reconnaissance data, our first survey maps of the new world. From these clues, a thesis was born, an ingenious connection was made. We would not use brute force. We would not wage war on the cosmos. Instead, our gateway would be an act of cosmic alignment, a masterpiece of finesse. We would find the perfect place, provide the catalyst, and allow the universe's own deepest mechanics to open the door for us. From this thesis, a construction plan emerged, a multi-millennial project of robotic vanguards, of taming a black hole, of playing a symphony of gravitational waves. We took the impossible and rendered it into a sequence of achievable, albeit monumental, engineering tasks. We have, in this journey, drafted the most ambitious blueprint in human history. But the ultimate question remains, why? Why engage in this mental exercise? Why contemplate a project whose completion lies in a future so distant we can barely imagine it? The answer is the very soul of our channel. the heritage of the stars that beats within us. We do this because the act of conceiving the impossible is the engine of all human progress. The Multiverse Gateway is more than a theoretical megastructure. It is a symbol of the unwavering human refusal to accept limitations. The same spirit that looked at a river and conceived of a bridge, that looked at the sky and conceived of a wing, now looks at the fabric of reality and conceives of a gateway. The scale has changed, but the fundamental impulse is identical. It is the drive to understand, to reach, and to build. Thinking about these grand projects matters today, right now, on Friday, August 22nd, 2025. It matters because grand challenges are what push our science and technology forward. The mathematical models we might develop to understand brain resonance could unlock new secrets in material science or energy production here on Earth. The computational systems we would need to simulate such a project could revolutionize medicine and climate science. The greatest dreams of engineering are never just about their final goal. They are about the explosion of innovation and discovery they create along the way. They stretch our intellectual horizons and inspire the next generation to ask even bolder questions. They are the catalyst for our evolution. Ultimately, the legacy of a project like this is a transformation of perspective. For all of history, humanity has been defined by its finitude, cradled in a single solar system, within a single galaxy, within a single universe. We have looked out at the silent, starry night and felt both awe and a profound sense of cosmic loneliness. The Gateway changes that forever. It recasts humanity's role from that of a solitary island of consciousness in an empty ocean to a member of a vast, interconnected archipelago of realities. It suggests that our destiny is not bound to the eventual fate of this one universe, but is as limitless as the multiverse itself. It is the ultimate answer to the question of our long-term survival and purpose. Look up at the night sky. Each point of light represents a challenge, a destination, a mystery. For millennia, we have been content to merely observe them. The era of cosmic engineering is about the shift from observation to participation. We are the children of the stars, composed of their dust, powered by their light. The construction of a multiverse gateway would be the moment we fully embraced that heritage, the moment we stopped being just creatures of one universe and became citizens of the cosmos at large. It is not an escape. It is an arrival at a deeper understanding of our place in the grand, multi-layered tapestry of existence. The universe sets the rules. It presents the challenges. But it is our indelible defining nature to find the loopholes, to solve the puzzles, and to build the bridges. That is our ultimate legacy, to keep dreaming and to keep building.